This question could be the first question that you solve upon dynamic programming. Wait. Don't be scared by listening the name dynamic programming. If you follow step by step and try to visualize the question, dynamic programming could be really simple. You just need to follow the instructions and try to visualize the problem in your mind. As per the problem statement, you are given a staircase with n steps. At a time, you can either take one step or two steps at a time. And you need to determine the total number of distinct ways in which you can climb this staircase. I will show you visually and diagrammatically how you can approach this problem very easily. Hello friends, welcome back to my channel, a place where we explore the life of technology and make programming fun and easy to learn. First, I will explain you the problem statement and we will look at some sample test cases. Next, we will try to come up with a brute force solution to the problem and see why this is not a feasible solution. Going forward, I will show you how to attack this problem. I will show you how you can visualize it and how you ultimately build a solution. So that way you will understand the basic concepts of dynamic programming and how does memoization work. Going forward, we will also do a dry run of the code so that all of this sticks in your mind forever. So without further ado, let's get started. Let us first try to make sure that we are understanding the problem statement correctly. In this problem, you have to climb a staircase, right? And this staircase has total of n steps. You need to find out the total number of distinct ways in which you can climb this staircase. So what does that actually mean? Let us look at two sample test cases. In our first test case, you can see that the value of n is 2. This means that your staircase will have two steps to climb, correct? And how can you climb the staircase? So, one way to climb the staircase would be you can take one step and then another step, right? And then you would reach the top. So, you took one step and then you took one step again. So, this is one way. What is the other way that you can climb the staircase? You can also take two steps at a time, right? So, what this person can do is he can directly go over to the second step. And this is once again one more way to climb the staircase. So what did you do? You just took two steps at a time, right? And there is no other way that you can climb the staircase. So this gives you a total of two ways to climb the staircase. And hence the answer to this test case is 2 because you can climb the staircase in two different ways. Similarly, let us look at another test case. This time the value of n is 3. That means this staircase will have 3 steps, right? And here you are, you want to climb the staircase. How can you do it? One way would be very simple, right? You climb one step at a time. So 1, 2, and 3. You reach the top. So this is one way. Next, how else can you climb this staircase? You can also take two steps at a time, right? So what if I take two steps now and I'm remaining with one more step? So I take one step more. Once again, I'm at the top. So the path I followed is two steps and then one step. You have to find all the different ways, correct? So you can approach this problem one more way. What you can do is you can take one step at a time and then you can take two steps. Once again, you will climb the staircase. So this is one more way you can climb the staircase. So you took one step and then two steps at a time. Notice that there is no other way that you can climb the staircase. If you try to do two steps and then two steps, you cannot reach anywhere, right? Since this staircase only has a total of three stairs, right? So for test case number 2, 3 would be your answer because you can climb this staircase in a total number of three different ways. Now, if this problem statement is clear to you, feel free to try it out on your own. Otherwise, let us try to form a solution and see how we can optimize it. Okay, so before trying to find an optimal solution, let us try to figure out how we can approach this problem. A good developer will always try to come up with a brute force solution. That is because it can guarantee you that a solution to this problem exists. One way to approach this problem would be to identify all the number of distinct ways that you can climb staircases. So let's say your value of n is 1. That means you have only one staircase. And how can you climb it? You can just take one step, and that would be it. Correct? You can climb the staircase in only one way, right? Next, let us say the value of n is 2. This time you have two stairs, right? And how can you climb it? Either you can take one step at a time, or what you can do is you can directly climb two stairs. So there are a total number of two ways, right? Going forward, when the value of n is 3, that means you have three stairs to climb. And how can you do that? Either you can do one step at a time, one, or you can do two steps and then one step, or you can do one step and then two steps. So these are all the ways that you can climb the stairs, right? So when the value of n is 3, you can climb the staircase in a total number of three ways. Similarly, let's see what happens when the value of n is 4. As soon as the value of n is 4, you can climb these staircase in a lot of ways, right? So what you can do is you can either do one step at a time, or you can do two steps and then one step and then one step, or you can do one step and then two steps and then one step, or you can do two steps and then two steps again. So you see, you have so many ways to climb these, right? There are a total of 5 ways. So when the value of n is 4, you can climb the staircase in a total number of 5 distinct ways. Now, this approach is correct, and you will ultimately be able to find a solution no matter the value of n. If the value of n is 10, there will be so many distinct ways that you can climb the staircase. But at the same time, finding those combinations can get real hard. So you need to do something about it. You need to approach this problem in such a way that you are not calculating these results again and again. Let us see how we can approach this problem in a very smart and easy way. Rather than directly giving you the solution, I want to take some time and tell you how to approach these kind of problems. What should be your thought process and how do you approach this problem step by step? Let us say I have this staircase in front of me and this has a total number of 7 steps, right? You are standing over here and you want to reach the seventh most step and you have to determine the total number of ways. Forget everything for a moment. Let us say that you have to arrive at step 7, right? And what if the step 7 is your last step? How can you reach the last step? Either you would be standing on step number 6 and you will take one step over here, right? Or what will you do? You would be standing on step number 5 and your last step would be to take two climbs and reach step 7, right? So what I can say is that the total number of ways to reach step 7 will be either you climb one stair from step 6 or you need to climb two stairs from step 5, right? Think about it for a moment. Now that you know that these are the total number of ways, you are either climbing one stair from step 6 or you are climbing two stairs from step 5. So this problem can now translate into the number of ways you are reaching step 6 plus the number of ways you are reaching step 5. So that simply means that the total number of ways you can reach step 7 are the total number of ways you can reach up to step 6 plus the total number of ways that you can reach up to step 5. Because after that, you either need to take one step to reach step 7 or you need to take two steps to reach step 7, right? Just pause the video over here for a while and let this sink in. Based on this idea, we can come up with a very easy solution. So just stop over here and whenever you're ready, let's go. Okay, so now try to gather all the information that you have. What if you have only one stair and you have to climb it? How many ways can you do that? You can climb one step at a time, right? And that will tell you that you can climb the staircase in a one total number of ways, right? Move ahead. How can you climb two steps? The way to climb two steps would be either you take one step and then one step, or you can climb two steps at a time, right? So you can climb two stairs in a total number of two ways, correct? Similarly, what happens if you have three stairs to climb? Based upon our previous idea that if you have to reach step 7, that would be the total number of ways you can reach step 6 plus the total number of ways you can reach step 5. I can derive a similar formula. The total number of ways to reach step 3 will be equal to the total number of ways you can reach step 2 plus the total number of ways you can reach step 1. Now, what are the values that you know? You know the number of ways to reach step 2, that is equal to 2, right? And you also know the total number of ways you can reach step 1, and that is equal to 1. When you add up these two values, you will know the total number of ways that you can reach step number 3. And there are total of 3 ways, right? You know 1, 1, 1, or 2 and then 1, or 1 and then 2, right? Based upon this idea, if you have to reach step 4, that will be the number of ways you can reach step 2 plus the number of ways you can reach step 3. So you get a general formula to solve this question, and that will be the number of ways to reach step n is equal to the number of ways you can reach step n plus 1 plus the number of ways you can reach step n plus 2. So this is dynamic programming. Somehow in an array, you are storing the number of ways you could reach step 1, then step 2, then step 3, then step 4. And if you want to calculate how to reach step 5, that would be just the addition of step 4 plus step 3. And this is memoization. Once all of this is clear to you, writing the code for this problem is very, very easy. Just to sum everything up, let us have a look at it. On the left side of your screen, you have the actual code to implement this solution. And on the right, I have a sample test case where the value of n is 8. That means I will have a staircase that has a total of n steps, right? This n is passed in as an input parameter to the function. Oh, and by the way, the complete code and its test cases are also available in my GitHub profile. You can find the link in the description below. So what do you do next? You know that if you have only one step, you can only climb it in one way, right? So you simply return 1. If not, you move ahead. Now, what you do is you create a array DP that will store all the possible ways that you can climb these stairs. And how do you initialize it? You know that you can climb one step in one way and you can climb two steps in two ways. We have established this. So we will just populate this array. Now, moving ahead, you can subsequently calculate how can you reach step number 3. Reaching step number 3 would be 1 plus 2. So you can reach step number 3 in a total number of 3 ways, right? This loop will continue all the way up till n, right? So going forward, you can reach step number 4 in 2 plus 3, that is 5 number of ways. Then you can reach step number 5 in 3 plus 5 number of ways. That is a total of 8. Similarly, going forward, you can calculate all these values. 8 plus 5 would be 13, 13 plus 8 would be 21, and then 21 plus 13 would be 34. So you can climb 8 staircases in a total number of 34 distinct ways. And once you're out of this loop, simply return this answer. The time complexity of this solution is order of n. That is because as the number of stairs increase, you need to keep on calculating more and more values. And the space complexity of this solution is also order of n. That is because you need to maintain this dynamic programming array that will store all the previous values. I hope I was able to simplify the problem and its solution for you. As per my final thoughts, take a moment to realize how we came up with the solution. We just used two building blocks, right? We just determined that, okay, if you have to climb one step, what are the total number of combinations? And if you have to climb 2 steps, then what are the total number of combinations? Based on these two answers, I was able to determine the distinct number of ways to climb the third stair and then the fourth and the fifth, right? It was so easy. You just need to focus on the logic when you're solving problems on dynamic programming. Don't get scared by big words like memoization and oh my god, DP. What do you do about it? Never be scared. Just follow step by step what the problem statement is trying to say and solve a small portion. That small portion can expand into the entire problem itself. You see for yourself when you saw the code how small the solution was. This is the beauty of dynamic programming. What problems did you face when you were solving this problem? Can you find some other efficient methods? Tell me everything in the comment section below and I would love to discuss all of them with you. You would be also glad to know that a text-based explanation to this content is available on the website studyalgorithms.com, a pretty handy website for your programming needs. You can find the link in the description below. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I can simplify programming for you. Also, let me know what problem do you want me to solve next, or rather, what do you want to learn next. I'll be glad to help you out. Until then, see ya.